Paris, early winter of 1898. The city was cloaked in fog, its streets slick with rain and soot, and the air heavy with the scent of coal smoke rising from countless chimneys. Within the austere walls of a University of Paris, a small laboratory glowed dimly under flickering gaslight. Here, Marie Curie crouched over heaps of dense, powdery minerals, her gloved hands trembling from cold and fatigue. Around her lay uranium salts, thorium, and a mysterious, enigmatic substance called pitchblende. To the untrained eye, it was just rock and powder, but to Curie, it was a key to secrets no one else had yet glimpsed. For months, Marie and her husband Pierre had worked with these minerals, processing them in painstaking, often grueling routines. Extracting a radioactive element from tons of ore was physically exhausting, mentally taxing, and, by the standards of the time, perilous. Each day involved hours of stirring, filtering, and weighing with meticulous precision. Their apparatuses were makeshift, glass flasks patched with wire, iron supports cobbled from scraps, wood stands warped from heat and moisture. In these conditions, fatigue and frustration were constant companions, yet Curie moved forward with a determination that seemed inexhaustible. One afternoon, as she heated a flask over a small burner, an unexpected chemical reaction occurred. Fumes erupted in a sudden, brilliant blue mist, acrid and biting, filling the room with a strange energy. Most would have recoiled, but Curie leaned closer, notebook in hand, recording every detail. The reaction confirmed what they had begun to suspect: the element they sought was extraordinarily active, far beyond anything previously measured. In that moment, fear and exhilaration intertwined. The experiment had validated months of labor, hinting at the radical discovery that would soon transform science. Days and nights blurred. Curie's fingers were stained with chemicals, her skin marked by burns, her hair occasionally singed by sparks from makeshift burners. Yet she persevered. The lab became her world, a space of cold floors, flickering gaslight, and the ceaseless hum of activity. Her observations were recorded with surgical precision, every anomaly noted, every reaction tested again and again. Slowly, painstakingly, the Curies isolated minuscule quantities of radium from the tons of pitchblende they processed. Finally, in December, their efforts bore fruit. Radium was extracted in its purest form. A faint blue glow shimmered from the substance, ethereal, ghostly, almost magical in the otherwise drab laboratory. For Curie, it was not only a triumph of chemistry, but a vindication of her relentless labor and an affirmation of the power of human curiosity. The tiny glow, imperceptible to the naked eye in strength but undeniable in significance, was proof that the fundamental laws of matter could be bent, revealed, and transformed by patient intellect. The extraordinary aspect of this episode was not only the scientific discovery, but the human endurance behind it. Curie worked in conditions unimaginable today: no proper ventilation, rudimentary protective measures, constant exposure to unknown radioactive substances. Her body bore the price of her curiosity, yet her mind remained sharp, methodical, unrelenting. Friends and colleagues worried for her health, but her drive was unstoppable. Each success, each new observation, reinforced her determination to continue where others would have faltered. This discovery would ripple through medicine, physics, and chemistry. Radium's faint glow symbolized more than its radioactive power; it was a testament to the capacity of human perseverance and intellect. Curie's hands, trembling from fatigue and exposure, had held a substance that would illuminate the structure of matter, inspire future scientists, and revolutionize human understanding of the atomic world. In the small, cluttered Paris laboratory, among heaps of minerals, broken glass, and chemical residue, Marie Curie demonstrated the extraordinary convergence of intellect, courage, and resilience. She transformed danger, monotony, and exhaustion into discovery. Her work revealed not only the secrets of radioactive elements but the boundless potential of a mind dedicated to understanding the unknown. In the ethereal, ghostly glow of radium, one could glimpse the brilliance of a woman who refused to accept impossibility and, in doing so, illuminated a path for all of science.